This video will demonstrate how to set up a Helm repository on Google Cloud Storage. This will be a really clean, easy, serverless, and cheap way to run a Helm repository. This repository can be used to make our Helm charts accessible to colleagues or anyone on the internet. We're also going to use a custom domain name like charts.example.com and HTTPS for a professional-looking production-grade setup. If you follow along, feel free to use your own domain name. Or, if you prefer, just skip the advanced networking setup and get something simple running. We're going to use GitHub Actions for some workflow automation. Particularly, we'll automate the creation of the Helm repository index.yaml file and the publishing of the new Helm chart versions. Code is shared in the description of this video for your reuse. Let's quickly map out what we're trying to achieve here, and then we'll jump into the Google Cloud Console and GitHub to set this up. So this whole process starts with the Helm chart that you want to share or reuse. The Helm chart needs to be properly structured. We will not cover this prerequisite step in the demonstration. Rather, we will continue with the assumption that your chart is ready to go. We're going to push our Helm code to a remote Git repository on GitHub. And we're going to use GitHub Actions for an automated workflow to publish new chart versions. The automated workflow is ultimately going to create a gzipped tar files and the index.yaml file in cloud storage. These tar and index.yaml files will form the foundation for our Helm repository. In order to make our Helm repository accessible on the internet and over HTTPS, we'll use the Cloud Load Balancing service and a custom domain. So, with this setup, our users will hit the Google Cloud Load Balancing service, which is backed by that cloud storage bucket. And we're going to use Cloud DNS in order to set our custom domain for the Helm repository. If you choose to also use a custom domain, you'll need to have control over DNS records. We'll walk through Google Cloud's DNS service for our demonstrated setup, but you can certainly use a different DNS provider if you'd like. With what we're trying to achieve now established, let's go ahead and jump into the code, the Google Cloud Console, and GitHub Actions. I'll be using the Cloud Shell and Cloud Shell IDE for commands and code, respectively. This is a convenient service in that it automatically authenticates with our Google Cloud Platform instance and includes some useful libraries and CLIs out of the box. While we'll use a very simple Helm chart as an example, much more complicated Helm charts can leverage the exact same process. Alright, so we have a Helm chart that's named pod. We're going to cut out our first version as 0.1.0. The Helm values contain a single example parameter, which is the Nginx image that we want to run. In our templates, we are resolving this placeholder with that image value. Again, this is super simple, but should work just fine for our demonstration. As a reminder, this code is linked in the video description. With the code reviewed, let's now go ahead and jump into the Google Cloud Console, where we'll set up the required resources. Let's first set up the cloud storage bucket. This is a brand new project, so we may occasionally see API enablement screens. When asked about enabling APIs, we'll go ahead and confirm. If you're using a custom domain like us, you'll need to use that domain name for the bucket name and can also verify the domain with Google Cloud. We can click Learn More to open domain verification information. One of the simplest ways to do the domain verification is with the Search Console. When you open up that Google Cloud Search Console page, you may immediately be presented with this Select property, or if you've already verified some properties, you may have to select it over here. To verify this domain, we just need to add a TXT record to the DNS zone. While any DNS provider will do, the DNS zone for this domain is in Google Cloud DNS, so I'll open up yet another tab to set that up. In that tab, we're actually going to go to a different project where I already have the DNS zone set up. Let's paste in that TXT record from earlier. Great, so we have that TXT record. Let's go ahead and verify. We're good to go. With a verified domain, we can now close the Search Console and the associated documentation and go back to our bucket. We're now ready to continue here. Let's host our repository in the US, and importantly, we want to use the standard storage class to minimize costs. We need to uncheck public access prevention on the bucket and keep the uniform access control. We're demonstrating the creation of a public Helm repository, but if you want a more controlled or internal setup, you may want to change these access configurations. Alright, our bucket is now set up. Next, we need to set up the public internet access permissions. And on a related note, we'll need to set up the permissions that allow our GitHub Actions CI/CD system to push new Helm chart versions. So let's first create the service account for GitHub Actions. I'm going to click Create Service Account in IAM and Admin. Let's name the service account Helm Repository CI. We could grant the Storage Object Admin permissions at the project level here, but instead we'll use a more secure setup with individual bucket level permissions. So we'll continue here and click Done. Let's copy our service account email for future use and go back to our bucket. In the Grant Access interface, we're going to add permissions for our Charts bucket. Paste in the service account email here and then assign the object admin role so that we can create, update, destroy, and view bucket objects with our service account. The next step is enabling public access on this bucket. For that, we do yet another role binding here. We'll choose all users for the principal. However, importantly, we don't want object admin permissions here because we don't want any user on the public internet to be able to push files to our repository. Rather, we just want them to be able to view and use the Helm packages in this repository. So we're going to do Storage Object Viewer here. We'll get a little warning which warns us about making the bucket public. However, we're doing this intentionally. Moving right along, we'll go back to the IAM permissions page to generate a service account key for our upcoming GitHub Actions automation work. Let's generate that now. Okay, so we're looking pretty good on the permissions and keys. We're going to leave the Cloud DNS Browser tab, as we'll need it to set up an A record for our subdomain shortly. Back to our main tab, we can start to set up load balancing. If you get this error that the server was not able to fill your request, know that you probably need to enable the Compute Engine API. That's our situation now, so let's switch over to the Compute Engine and click to enable the API for the project. Getting back to load balancing, let's create a load balancer. We'll use the global HTTPS load balancer, which takes in traffic from the public internet. We want to serve our repository exclusively on HTTPS, so let's force HTTP to HTTPS redirects. That redirect configuration requires a static IP, so let's set up that as well. Now that we have a static IP address, we can enable the HTTPS redirect. We're going to have Google Cloud manage our SSL certificate for the HTTPS. In our backend services, we need to create a backend bucket. The backend bucket name can be anything, but for clarity, we'll give it a name that matches our domain. Next, we select our bucket. So let's go ahead and click Create. In our routing rules, we have a pretty simple setup. Namely, we want to route everything to that backend. That all looks good, so we can review and finalize here. It may take a minute or two for this load balancer to be created. Alright, our load balancer is totally created. In the console, it looks like there are two load balancers, but that's just reflective of the HTTP to HTTPS redirect. The two load balancers effectively act together. Next, we need to take our public IP for the load balancer and set up an A record for it. When that is set up, users will be able to interact with the repository using the domain charts.nomadic.io. Again, my DNS zone happens to be in a different project, so I'll switch to that and set up the A record. Now, Google Cloud can run an HTTP ACME challenge and be able to provision an SSL certificate. The certificate provisioning will usually take just a few minutes. While that's provisioning, let's go ahead and work on the GitHub Actions portion of our setup. Looking back at our diagram, we've so far focused on this piece of the problem, which is our cloud infrastructure running on Google Cloud. However, we also need this piece here, which is the GitHub-based automation for publishing new Helm chart versions. So let's set that up now. We'll jump over to GitHub and sign in. We're going to create a new repository and, for the sake of demonstration, set it to be a public repository. Again, the link for this code is in the description of this video so that you can directly fork and play with the code. Let's now create the repository. If you haven't yet set up your Git credentials, you want to do that now so you can push commits. Let's go ahead and commit our Helm chart. Importantly, we want to make sure we don't have any secrets in the commit. So, when I look at the files, we shouldn't see anything like JSON service account keys. What we commit will be publicly accessible. Let's check the diff to make sure that we're not committing any secrets or sensitive configurations. This is looking good, so let's do an initial commit with these files and then push the commit to GitHub. If we refresh, we now see our code. Great. The next step is to introduce a workflow for automated Helm repository management. First, we need a GitHub directory and a workflows directory inside it. We're going to do a Helm publish operation in this YAML file here. We'll build out the configuration piece by piece. The first piece of the configuration is a name and workflow trigger configuration. For the triggering, let's initially run the workflow on every main branch push. In steady state, we'll use Git tags to dictate Helm chart publishing. For the next section, we'll specify the use of Ubuntu and check out our code. Next, we want to install the gcloud CLI for commands that interact with Google Cloud. So the code is going to look like this, and we're going to use secrets for the project ID and the service account key. Remember, the service account key is right here. So we're going to use that in GitHub to securely publish our Helm repository. Next, we're going to do some Helm steps, installing the Helm, linting the Helm chart, and then packaging things up. Then, to publish that packaged Helm chart, we'll run a gsutil copy command. Finally, the most complicated step is generating and pushing an index file. This index file provides Helm clients with information about the Helm repository. To generate the index.yaml file, we'll make our Google Cloud bucket look like a file system using GCS views. We'll then run a Helm command to generate the index file. With the bucket mounted, the Helm CLI will see all the available charts and dynamically generate an index.yaml file. This command here will generate that index.yaml file. Then we just need to use gsutil to copy that to our charts bucket. Again, there's no need to type out these commands because you can go to the GitHub repository linked in the description of this video and copy-paste. When you do that, you'll just need to change the configuration to match your specific domain. Great. So before we commit and run this, we need to create the two prerequisite secrets in GitHub, the project ID and the service account key. So in the GitHub settings, navigate to the secrets page. We can get the value for the first secret from the Google Cloud homepage here. So our project ID is Helm repository demo. The second secret will be populated by the contents of the service account JSON file, which downloaded earlier. I'll copy that content into the GitHub secret off camera. Great, so we have our secret set up and can push our code. With the JSON having served its purpose, we can now remove it. We'll also add the new GitHub workflow. Okay, when we go to the repository, we should now be able to see our GitHub Actions workflow running. Let's jump into the workflow logs where we can check for errors and debug as needed. It looks like this all worked flawlessly, so let's check out our Google Cloud Storage bucket. So we have our Helm chart with our version 0.1.0 published. If you're wondering where this version number came from, it's in fact the version provided in the chart.yaml file. We also have this index.yaml as expected. We can actually download this file and check its contents. This view gives us a better understanding of how this is valuable. So here we see the digest for that Helm chart version, along with the name. So now, when clients want a specific version of this pod chart, the repository can point them to the right tar file. Let's return to our load balancer to see if our certificate from earlier has finished provisioning. Specifically, we click into the HTTPS load balancer and check the certificate. Great, the certificate is looking good. If we go into our IDE, we can test the full setup using a Helm repo add command. That ran successfully, so our Helm CLI client can traverse our networking and see that index.yaml file. So at this point, we've set up and tested our GitHub Actions, we've created the required serverless resources on Google Cloud, and we validated the networking. Let's now test the full setup from an end user's perspective and see if we can use this chart for a Helm install operation. For this test, we'll need a real Kubernetes cluster to install our resources on. After the required GKE API is enabled, let's create and configure a new cluster. We'll keep this cluster up for only about 10 minutes, so we don't need to worry much about the cost and can keep most of the defaults. I'm going to reduce the node size down to 1 to reduce the cost a bit. Alright, with that cluster now created, let's jump back into our Cloud Shell and see if we can authenticate. There's our cluster. This command establishes authentication with that cluster so that we can use kubectl and Helm commands. If we run a test kubectl command, we can see the authentication working. So all that's left to do is take our Helm chart out for a spin. Remember, the Helm chart repository must be added before it can be used, and we did that step earlier. If we run that same command now, it shows that we already executed the repository setup in our client. Okay, so let's install from the Nodomatic repository and use the pod chart. We'll generate a name instead of providing one explicitly. This will deploy in the default namespace since we didn't specify something else. If we check the pods, we now see the Nginx pod running. Great. So, just to recap what we've achieved in this demonstration. First, set up some Google Cloud resources to create a Helm repository. Specifically, we leveraged the serverless cloud storage and cloud load balancing services. We needed to manage some DNS records, and in our case did that with Cloud DNS. Recall that we needed both a TXT record for domain verification and an A record for standard domain resolution. We used the GitHub repository and GitHub Actions to automate the creation of an index.yaml file and chart version tar files. Since we've now established a baseline setup, we might want to change the publish conditions to just follow Git tags. With that new triggering condition in place, we need to explicitly tag our commits to get the GitHub workflow to create a new Helm chart version. We'll want to match our Git tag name with the Helm chart version specified in our chart metadata. To illustrate, note that we don't have a workflow running right now. Rather, we now need to tag commits as you see here and push them. Back in our bucket, we now see that chart version available alongside our original version. Both versions are cataloged in our index.yaml file. Let's finish up this video with a very quick note on costs. In this setup, your cloud storage costs are going to be quite small. Typically, the cost will be less than a few dollars per month. However, the cloud load balancing can be higher at about $18 per month. The total cost for this setup is then about $20 per month. That includes Cloud DNS cloud storage and cloud load balancing. We're assuming here that you're on a free version of GitHub version control and GitHub Actions. We hope that this setup is well worth the cloud costs for you and that you can have some fun using and customizing the architecture. Thank you for watching, and feel free to post any questions in the comments.